This is the 8th video of the PreventSARS3 video series, and I will explain NL63 and MERS viruses. NL63 is estimated to started to adapt around 800 to 500 years ago. So it's the oldest coronavirus actually, and its symptoms are like common cold, endemic to human. It doesn't have it lost its sialic acid binding capacity, as I indicated in the model, to get rid of the host immunity. But its spike protein receptor binding domain, it's still functional, and it's trying to adapt to its host with different mutations. And this is the non-functional sialic acid binding domain. But the important point here is, even after 500 years of adaptation, the virus is still trying. Those are the blue ones, are the recent clinical mutants. So those are the isolates, high-frequency mutations. You can see the blue color mutations. And there are lots of inserts and deletions, actually mostly deletions, probably indicating the loss of sialic acid binding domain capacity. This is the N-terminal domain of the spike protein. So this is the receptor binding domain. Actually, it's using the same receptor, ACE2 receptor, like SARS coronavirus 2. And if you look at this blue, those are the mutations. That's an ongoing adaptation after 500 years of human infections. It's still mutating on its receptor binding domain. It doesn't have that perfect interaction like SARS-2 probably, but also you can see during the host change, this area is not it's not the bat coronavirus area any longer. You know, this receptor binding domain heavily mutated. I want you to get this understanding about how the natural things happening, what's natural order. And this is MERS. It started to infect human in 2012. You might find other viruses very old and not reasonable to compare to different their parent SARS or bat or rat viruses. But no, this is also having the same transition, adaptation, digestion pattern in their new host. So I think it's the most similar virus to SARS coronavirus 2, because also it has furin cleavage capacity. But the important point here is this is a virus capable to kill 40% of the infected patients. So SARS-2 unfortunately could evolve into something like this. Well, I'm sure you think the other viruses adapted 800 years ago, 200 years ago, but that's a 2012 adaptation. And as I say, this is the model fitting to this virus perfectly. You can see this is the sialic acid binding domain, these italic areas. Its sialic acid binding domain is sunken, heavily mutated on this area during host adaptation, and it's still trying to improve its sialic acid binding domain activity, maybe evade the host immunity. So this is the confirmation of the model with a very recent example that adaptation has a cost, genomic cost, genomic damage cost, and it has some signs like this. This is the image, this is the picture of the adaptation to human in coronaviruses. And this is the receptor binding domain of MERS. Also, this is heavily damaged during its adaptation. And also, as you can see, MERS is mutating on its receptor binding domain. And that's first, it heavily changed itself during adaptation and then its receptor binding domain is also continue to change. Those blue areas are ongoing mutations.